data engineer at Indigo Ag, which is an agriculture tech startup company based in Boston. Today, I am here to share a few of the cool use cases of the distributed data processing, especially in the agriculture sector. So, on a very funny note, I am a foodie, and we all know that we are very good at consuming food, but we are not equally that great understanding how the food is being produced, right? So let's set the stage, let's set the mood to agriculture for 10 minutes of time. So let's talk about agriculture a bit, and then we discuss about the data processing. In a typical farmer's day-to-day life, in a crop life cycle, he spends a lot of time thinking about what crop he needs to cultivate and what kind of yields it's going to give and whether it is going to be a profitable or not. These are all many questions runs through any farmer's mind before he decides upon. So at a very high level, this is a typical crop life cycle. First, he needs to select the crop. He has to choose whether that is profitable for him or not, whether that is going to work for him or not. And then he needs to go for the next step as a land preparation, how much land he has, and getting ready the land prepared for the next crop season. And then he needs to select the seeds because, again, it's a huge market. There are multiple different brand type seeds available in the market. He has to select out of one. And then seed sowing, and then irrigation, providing the water supply, and then he's continuously monitoring the crop growth. And in between, if he needs to put some kind of fertilizing, he needs to provide to the crop. And then harvesting, meaning to say once the crop is ready, that is when we separate the grain from the crop, and then the grain needs to go into the storage, and then go into the marketplace where some buyer is going to buy the grain, and then finally the logistics part of it, how we deliver the grain. So this is a very high-level crop life cycle. Many agriculture tech companies work on different aspects. Some of them work only on the logistics side, some of them work on the marketplace side, some of the agriculture tech companies work on the greener side more, like the soil characteristics and the soil nutrition, how to track the field events over a period of time and all. So my company does mix and match most of the agricultural things in the tech-savvy way. So this is a very publicly available information on the United States Department of Agriculture. Here I am talking about the soil health. So in order to keep up the soil health, we'll have to follow certain practices, like you minimize the disturbance to the field. So you should not severely tillage the field. That may erode the soil and some of the nutrients may go away. And also you have to maximize the soil cover and also maximize the biodiversity and integrate your farm fields with the livelihood, livestock, and also minimize the presence of living roots, maximize the presence of living roots, like don't too much dig into the plants and take out the complete roots. So these are all certain practices that our Department of Agriculture suggests to any farmers to improve the soil health. Out of all these characteristics, carbon is one very important element that plays a very vital role. So carbon try to keep the structure of the soil stable, and also it improves the, it holds a lot of water and it reduces the water content, and also it tries to absorb the carbon from the atmosphere and keep it back into the ground. And as a field which is having good carbon levels also pushes the nitrogen levels of the field to be improved, which further increases the nutrients of the soil, which gives a better productivity, better yield, better profitability. So these are all different things. So as an agriculture company, we really would like to track what are the historical events that had happened on a particular field. And there can be many ways that we can track. The one simplest way is the farmer himself or herself intimates us that what are the different events that are being taken place in the field. But that's not a very high efficient mechanism because farmers are super real hard workers and they won't be having a lot of time to update all the data into our systems. So we have to have some cross-check about missing data points, so how we really would like to track that. And at the same time, in United States itself, there is about 900 millions of cropland. Imagine about the whole world. Imagine about the total surface of the planet Earth. So if you want to keep tracking of every field, what had happened through manual process, that is almost next to impossible. And you can go another route where you install some IoT sensors, but at the same time you have to invest a lot of cost in installing those sensors, maintaining those sensors, gathering that information from them. It's again a trivial process. So, and also the field events are not time bound, meaning to say it's not about setting a timeline and every farmer needs to follow that strict timeline. It won't work that way. There is a lot of flexibility where the farmer can decide himself about the crop life cycle in a way that when he is ready to put the seed, when he really thinks that the seed needs water, and these are all not time bound by everybody. It's individual farmer, individual field. And also field boundaries can change over time. It can be sounding a little confusing, like how a field boundary can change because two fields can get merged together, and or else some of the field can be converted into a construction part, or it can be changed into a non-agricultural land. So these are all certain changes that really changes the field boundaries over a period of time. And also, and agricultural data is very disparate in nature in the sense it's not like a typical CRM or ERP solutions where you have employee ID and department ID and have the joins and all. It won't work that way. It's more of like a satellite weather data, water index data, historical crop events data. These are all not to a very attribute specific. So we'll have to find out a common granularity where we can get these all disparate data systems together and try making a story out of it which makes sense, like, okay, for this particular region, these are the water levels, these are the historical crop events, these are the historical carbon levels, and you relate that information to some of the other disparate systems. So out of all these practices that I have discussed so far, I think either it is super manual or it is super costly approach, installing the IoTs, drones, or regular field, what you can say, visits, monitoring things and all. Rather than that, if we leverage on satellite imagery, where we publicly get the data from NASA, from many other organizations, and almost for free on a public cloud storage where you can get the data and then start analyzing the data. So, so here what I'm trying to talk about is that the satellite imagery processing. For example, if you take Sentinel-2 data, it is hosted on a public storage, and the data refreshes at every 10 days, and the image data is stored in a cloud-optimized GeoTIFFs. We also call it as COGS, and it is a super big in size. You just imagine about the satellite imagery of the complete Earth, right? So this is a very random image. I just zoomed right onto the Google Earth and then tried capturing this image. You can see there are different fields over there. Some of them are green in nature, some of them are gray in line, some of them are semi-gray. And these are all different textures which can easily indicate that the greens are probably some crop is there in the green lands, whereas the gray areas where those rounded circle lines, that is something tillage to prepare that land for the next crop season. And some other areas where some green, some semi-grow, where it is not being tillaged or not being cultivated with a crop at this point in time, as I have taken that image. So if you go with a higher resolutions and you can go up to the leaf of a crop plant and then say what crop it is. And also if you fertilize it, there will be some fertilizing white color marks on the leaves where you can say that, yeah, this crop has been fertilized recently. Or if you see only the gray circle lines, it's a very easy identification that the tillage had happened. So why don't we leverage this satellite data, and every 10 days we process the data and compare what we have in the previous process to the current process, and then decide what are the field events that happened. And then cross-check with the respective farmers, and then say that, hey, we found out a tillage event on your field. Is that true or false? So these kind of data points which helps us to the data fullness, where we can believe in the data and then start analyzing it, right? And now, as I mentioned, the tricky part is that geography, if you take planet Earth, it is round sphere in shape, and the geographical spots of every particular latitude and longitude is constant. It is not going to change, right? So there is a system called H3, which is called hexagonal hierarchical geospatial index. At a very high level, the concept behind this is that you imagine the planet Earth's surface segregated into multiple hexagons and polygons, and it's a parent-child relationship. As you zoom further in, every hexagon further gets divided into multiple sub-hexagons and pentagons. As you go further and further, as you go deeper into the resolution, every hexagon further evolves as multiple other hexagons. So in a sense, what we are trying to achieve here is that at a very particular spot, what is the H3 index for that particular physical location of the geography, right? Out of curiosity, if you would like to know what is the H3 index for this particular room while we are talking, you can go and check it on h3.org. Or if you want to check what is the hexagon index that covers the city San Francisco. So these are all like stable and constant. It won't change per the algorithm. So how the parent-child relationship happens here is that as you use the index, it's a alphanumeric character, and as you navigate from left to right, you will be discarding each character, and it's going to move up to one parent level hierarchy. That is how you will reach to the top level hierarchy. So this is a United States map. We used about the 12 resolution there, which almost gave 30 billion pentagons and hexagons of the United States map at a resolution 12. If you increase the resolution further, like 13 and 14 and 15, it further divides the land into multiple sub hexagons and pentagons. So now here is a very high level data flow. So I discussed about the H3 hexagonal thing. And also I discussed about the challenges of tracking the agronomy field events. Now, every time when I process the satellite imagery data, I'll have to have some reference to compare from the previous process to the current process. So I'll have to have that connection. So that index is the key element. So that is where I'm trying to connect these two. Like the H3 gives the index and identify for this index what are the fields associated and what were the field events that had happened in my previous data processing and what are the field events that I found in this and the next data processing cycle, and then make a comparison, then you would be able to understand is there any events that really had happened. So that is a better, efficient way of less costly, I mean to say, less costly way of tracking the field events rather than putting a lot of manual effort and resources and installing all the sensors and all. So it's a very high level data flow. First we get the field boundaries data, and then we index using the H3, and then we use the disparate data systems. Like for example, you have the weather data, you index it to the H3, you have the historical crop events data, you index it to H3, and you have the historical agronomy events, field events data, you again index it to H3. So when you index all the disparate systems, the H3 index is the common denominator or the key attribute which ties all those systems. And then you can visualize the data in there. You can use many visualization tools like D3 or Plotly, or you can use many visualization tools which are available in the market. So if you the advantages of indexing the data, one of the demos what I'm showing here is that I created the we created the hexagonal tiles. So each tile can act like a partition. So every time when I want to process the data, or when I want to process the complete set of data, I'll go by the tile by tile, tile by tile, hexagon by hexagon. So that is how I reduce the data processing cost by not overwhelmingly auto-scaling it, right? So, and also there is another example I was talking about where we have the field boundaries can change. If you take the first image, in that the total image is being segregated or the H3 indexed. And in the right image, let's say the first one image was processed 10 days ago, and the second image is processed 10 days after, then you would be easily able to see the difference between both the fields, that the field has been split into two. One, the crop is continuing on the field one, whereas the field two is getting prepared for the second season or something like that. So you will be able to, so for each hexagon, it carries a centroid and the boundaries of a GeoJSON with a latitude and longitude polygons. So you will be easily able to calculate the area of the field, the boundaries of the field, and if the field is split into two, then you will be able to create two different identifiers for the field. And these are all different use cases of this. So I think that's all I have. So if you guys have any questions, I haven't touched upon the details about what Spark cluster configuration we have used, as we are talking about huge data sets, petabytes of data, terabytes of data, and also the image, unstructured data, processing that are leading to a lot of challenges, like many of you guys faced, and we also faced the performance issues with the Spark clusters and how we optimized it. And Some of the information that I could able to share, but some of the information is having some proprietary information, so I would not be able to present it, but I'm happy to discuss with you guys offline if you really would like to know about those details. Yep. I think that's it from my end. Yeah, cool.